Okay, so this is D8, this is page 20, and this is on something called L'Hopital's rule. So, remember back when we had our limit techniques and there were like, I kind of had like a flow chart of like what you could do. And we have to add to that. If you don't remember that, I'll refresh our memories in class. But we can add to our list of limit techniques L'Hopital's rule, now that we know derivatives. So it goes like this. So if you've got one of two things. So one, the limit as x approaches a of f of x over g of x. Okay, so if the limit of the top is infinity and the limit of the bottom is infinity, in other words, you get infinity over infinity. Okay, so that's one. That's called an indeterminate form. Or two, the limit as x approaches a of f of x over g of x equals 0 over 0. That is another indeterminate form. So what that means is basically not enough information to say what the limit is or if it even exists. So if you have one of those situations, then you could say by L'Hopital's rule, we should look him up. We should ask ChatGPT about him in class. So therefore, by L'Hopital's rule, the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of the derivative of f of x over the derivative of g of x. Okay? And then, so what that will make it do is like possibly, yeah, so anyway, so this is going to happen, guys, and then we'll try to plug in, so we'll do direct substitution, and if we get one of these forms, we can say therefore by L'Hopital's rule, and then we could open up another limit, but instead of the top, we take its derivative, and then instead of the bottom, we take its derivative, and it will be the same as the original. And then we try to plug A in again and see if we get like an actual number. Or we can definitively say does not exist. Okay, so anyway, let's do it. So here's this. So the limit as x approaches infinity of x squared over e to the 3x. So x is approaching infinity. So this means that x is growing. X is getting bigger and bigger. So as x gets bigger, this top just keeps on growing. The bottom just keeps on growing. And so in that case, we have infinity over infinity. Okay. And now, because you have this form, you could say, therefore, by L'Hopital's rule, the limit as x approaches infinity of x squared over e to the 3x is equal to the limit as x approaches infinity ddx of x squared ddx of e to the 3x. Okay, so the top one is a one step. The bottom is not. Okay, so off to the side, guys, I'm going to go like this. So off to the side, I'm going to say let u equal 3x. Okay, and then I'm going to be able to do a u substitution to, get a one-step derivative for the outside. But guys, when we do this, okay, from now on, if we do a u off to the side, I am immediately underneath it gonna go du dx and find it. So du dx, that's the derivative of u with respect to x. So du dx is the derivative of this, ddx of that, and so that's 3. So when I see du dx, I could plug 3 in for it. Okay, So I had to do the u substitution. So this is equal to the limit as x approaches infinity, d dx x squared over d dx e to the u. Okay, so the top is a one step and the bottom is a one step with chain rule. Okay, so I'll just use a highlighter to write like what they are. So this top right here is 2x, okay? And the bottom is du dx, and then the derivative, as though u were the variable, is e to the u. Okay, so next line, I've got the limit as x approaches infinity of 2x over, okay, now du dx, I already found that off to the side, that's 3, okay? And then e to the u is e to the 3x. Okay, that would go back in there. So this, in the bottom, okay, in the bottom we have 3e to the 3x. Okay, and then guys, you try it again. Okay, so imagine what's happening. So the limit of the top is infinity. Okay, the limit of the bottom is infinity. Okay, so you look at their limits separately and you get infinity over infinity. So we're still getting an indeterminate form. But guys, anytime you get an indeterminate form, like it's one of these, then you could use L'Hopital's rule again. Okay, so okay, so since I'm going to say therefore by L'Hopital's rule again, let's go like this. I'm going to go like that at the top, and I'm going to go star and circle it. So you could use symbols to identify for your reader like something that you're referring to from earlier in your work. Yeah, so I'll say it again. So I'll say therefore, but this time I'll say by star with a circle, and they'll see L'Hopital's rule. And then I'll just go to the limit. Limit as x approaches infinity of the derivatives. d dx 2x, and then, all right, I'm going to use I got to use u sub again on the bottom, guys. If you don't mind, and I'm not going to write, I'm going to skip a step. So this 3x, remember over here, that's u, so I'm just going to let it be u again. It's the same u. So even though I'm doing a different chain rule, I'm still using the same u. So down here, I'm going to go d dx, and then that's 3e to the u. Okay. Alrighty. Now, so this is going to be the limit, infinity. The derivative of the top is just 2. And now the derivative of the bottom. So the derivative of the bottom, it's a one step but with chain rule. So du dx times 3e to the u, or I'll just write it, 3e to the u. All right, so that's what that bottom derivative is. But remember that du dx is 3, and in for the u goes a 3x. Okay, so we're ending up with 3 times 3, so this is 9e to the 3x. Okay, and then you try it again. So x is approaching infinity. The limit of the top is 2. The limit of the bottom is infinity. So guys, if the top is staying 2 and the bottom is just growing and growing and growing, that entire fraction is shrinking down to 0. So the answer is 0. And guys, as we were doing this, I was thinking to myself, you didn't actually need L'Hopital's rule. Like say you're on multiple choice, okay? Free response, I think you'd want to go through this, or like, I'll actually find out about that. But I would go through this on free response. But on multiple choice, you could just do like the bottom outgrows the top sort of thing. So remember, e to the x will always outgrow ax to the n. Okay, e to the x is an exponential function, ax to the n is a polynomial, and exponential outgrows power. I'm sorry, power function I meant. Okay. Alrighty, I'll discuss that more in class as well. But that's the answer is 0. Okay, let's do this one. So the limit as x approaches -1 of this. Okay, so this time, x is not approaching infinity, it's approaching an actual number. So in infinity, you can't direct substitute. You just have to think about what's growing faster. But with an actual number, the first step is direct substitution. So 2 natural log 1 over, if I plug in -1, it's that. Guys, natural log of 1 is 0. Okay, so that's a fact we need to know. Natural log of 1, boom, that's 0. Over e to the 0 is 1. All right, so that's 1, so that's also 0. So 0 over 0, that is another indeterminate form. So then I could go right into L'Hopital's rule. All right, so I'll say, therefore, by L'Hopital's rule, I don't know, I want to say, like, I don't want to jump right into the limit. It feels like not smooth. So, but you guys, if you just jump, if you say therefore by L'Hopital's rule and you jump right into taking the derivatives, that's fine. But therefore by L'Hopital's rule, this limit, I'll say this limit, that works. This limit equals the limit as x approaches -1. Okay, guys, all right, I'm gonna split this up. Okay, so I look at the top is just one term, but the bottom is 2 terms. Shoot, actually, let me do this. I was about to skip a step, but never mind. Okay, so there's that. All right, guys, now, in the top, is this a one step? No. In the bottom, is this a one step? Well, there's 2 terms. So this term, no, it's not a one step, but this term, yes, it is. And yeah, also, guys, this is a constant term, so it doesn't matter what the variable is. But anyway, I think I'll separate those. I think that'd be good. Okay, so I'm going to need U substitution for both of them. I'm going to need chain rule. So in the top, so off to the side, I'll say let U equal -x. That's what will make the top a one step. And then in the bottom, what would make this first term a one step? That would be, I'll use W for the bottom. W equals 5x plus 5, okay? All right, so off to the side, we're gonna do that. Now, we're gonna go du dx on this one and dw dx on that one, okay? So du dx is d dx of this, and that is just -1. dw dx is d dx of this, which is 5. So now we can plug those in when we do the chain rule. Okay. All right, so let me move over here so I have room. So this is equal to the limit as x approaches -1 dx to ln of u over ddx e to the u minus d dx of 1. Okay, so I split those up in the bottom because one of the terms needed chain rule but not the other one. This should be w. Okay, so now everything is a one step, but we've got some one steps with chain rule. So this top one, the derivative is, sorry, I'm running out of room. The derivative is du dx times 2 over u. Okay, that's that whole top derivative. Okay, now in the bottom, that's a one step with chain rule. So dw dx e to the w. And then that is 0. Okay, now, okay, so du dx is -1. Okay, so this entire thing here is -1. And then 2 over u, u is -x. All right, so you could do this in your head, but I'm just kind of showing what's going to be going back where. All right, so that's going to be the top. And now in the bottom, dw dx is 5. Okay, so 5 is going in for that. And then in for w is going 5x plus 5. Okay, so this is the limit as x approaches -1. In the top, -2 over -x. Okay. Wait a minute, that doesn't seem right. Oh yeah, it does actually, okay. All right, so -2 over -x, and then in the bottom, 5e to the 5x plus 5. Okay, so this is what we've got. And all right, so these are going to be positive, all right? And now something I could do is keep, change, flip. All right, so if I put that over 1, and then I keep, change, flip, all right, so I'm going to be taking this and like flipping it up there. I get the limit as x approaches -1. -1 over, oh no, this is going to work. Okay, -1, and it ends up being 2 over 5x e to the 5x plus 5. Okay. All right, guys, I'll cut the video off after this. I wanted to do one more. And then this is equal to 2 over -5 e to the 0 equals -2 over 5. Okay, so that's the answer for that one. So it's taking me a long time because I'm showing a lot of very detailed notation. But as I've said before, you could do a lot of that just in holding the move in your head. Okay, guys, this one I'm going to have to make a second part for.